This is half past paper, week 15, foundation tier, and these are all the topics that we're going to be doing today. So this is half a past paper. We've got 42 marks on this paper, so 38 next week, and these are all of the Sparks codes if you do have access to Sparks. This is a calculator paper this week, so make sure you've got your calculator handy. Okay, question number 1, write 0.37 as a fraction. So to write this as a fraction, we want to say this is the digits 37 divided by 100 because it's been moved 2 places to the right. 37 hundredths, 37 divided by 100 is 0.37. So we can't simplify it, and even if we could, we wouldn't need to. It's only a 1 mark question. 37 over 100 is your answer. Question number 3, simplify 3e minus e, add 4e. Now remember that e on its own is 1e. So I've got 3e, I'm subtracting 1e, which leaves us with 2e, and then we're adding 4e. So this is 2e, add 4e, which is 6e. Question number 5, here is a list of numbers. From the numbers in the list, write down a cube number. So your cube numbers are 1 times 1 times 1. 1 cubed is 1, so that's your cube number. 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times that by 2 and we get 8, so 8 is a cube number. 3 cubed, well that is 3 times another 3 times another 3. And 3 times 3 is 9, times that by 3 and we get 27. So 27 is a cube number. So we would pop that down there. Out of interest, the next one, 4 cubed, 4 times 4 is 16, and when we times that by 4, we get 64. So good to know those numbers. They are your cube numbers. Question number 7. Farhad, George and Tom each did a test. Here are their marks for the test. So Farhad got 74, George got 77 and Tom got 72. George drew this bar chart to show the marks that they got. The bar chart is not fully correct. Write down 2 things that are wrong with George's bar chart. So the first thing I would always check is the y-axis. Now the y-axis is this axis here, and we can see that because this is 0 and this is 71, that square goes up by 71, and then we go up in 1s, 72, 73, 74, 75, 76, 77, 78. So we're not going up by the same amount each time. So the fact that it goes from 0 to 71 is misleading, and that square is worth more. So each square on the y-axis should go up by the same amount each time, or each square. And then also we've got Tom's bar, which is wider. So the bars should be the same width. That would be the other thing that's wrong. Never, ever, ever is the answer, it hasn't got a title. I see that answer all the time, and that's never it. So don't write there needs to be a title, because there doesn't need to be. That's absolutely fine. Okay, question number 9. This scale can be used to change between kilometres and miles. Use the scale to change 40 kilometres to miles. So 40 kilometres, we're looking on this side for kilometres and this side for miles. 40 kilometres, if we go over, it's going to be bang in the middle of 20 and 30, so we would say 25 miles. There we go. Here is an approximate rule to change from kilometres to miles. Divide the distance in kilometres by 10, and then multiply by 6. Use this approximate rule to change 40 kilometres to miles. So we've just done 40 kilometres to miles. Now we're doing it in a different way. We're going to use this rule. So 40 divided by 10, that's 4. And then multiply by 6. So 4 times 6 is 24. There we go. Compare your answer to part B with your answer to part A. Well, they're fairly similar answers. So both methods give fairly similar answer. Give similar answers. But you were pretty much allowed anything there. The mark scheme was very generous about, the differences and the similarities there, but I would say both methods give similar answers. They're both quite good approximations. There we go. Question number 11. Here is a cuboid. Work out the volume of the cuboid. So with any prism, when you have a shape that is the same cross-section the whole way through, you would do the area of that cross-section and times it by how far back it goes. So for our cuboid, I want to do the area of this end shape, this cross-section, and then take that answer and multiply it by 15. So the area of the cross-section is that rectangle, which would be 4 times 10, which is 40 centimetres squared. We're then going to take that area of 40 and times it by how far back it goes. So 40 times 15 is going to be 600. Now we've got no units on the answer line here, so we need to make sure that we put some. If it's volume and we're working in centimetres, that's going to be centimetres cubed. 600 centimetres cubed. Question number 13. A machine fills bags with sweets. There are 4,275 sweets, and there are 28 sweets in each full bag. The machine fills as many bags as possible. How many sweets are left? Now, a lot of students here did the correct first step of 4,275 divided by 28. We want to know how many fit in. So typing that in my calculator, 4,275 divided by 28 is 152.67857. But that doesn't tell me how many are left, it just tells me how many bags I can fill up. So I'm now going to write that I had 152 full bags. The 0.67 just means that I wouldn't be able to get another one. It's 2/3 full, but it's not quite going to be enough, okay? What I'm now going to do is say, okay, well, if 152 bags are full, and I know that each of those has 28 sweets in them, 152 times 28 is going to be 4,256. So now we know how many are left over by doing a subtraction. So 4,275, take away 4,256. And again, if you were doing that properly without a calculator, more on the floor, so we'd need to borrow from next door. 15 take 6 is 9, 6 take 5 is 1, and then we've got 2 take 2. 4 take 4, so 19 sweets left over would be your answer for that one. Well done if you got that. Question number 15. Work out the value of t when x is 5 and y is -7. And we've got this formula here. So we know that to get t, we need to do 3 lots of x, so 3 lots of 5, because that's what x is. And then we need to add on 4 lots of -7. So -7 goes there. So t is 15, that's 3 times 5. Add -28, that's 4 times -7. And when we're adding a minus, we're taking away. So 15 take away 28 is -13. And that would be my final answer. For part B, work out the value of y when t is 38 and x is 6. Well, let's fill in what we know. We know that t is 3 lots of x, add 4 lots of y. So 38, that's our t, is 3 lots of 6, because that's our x, add 4y, and we don't know that. Now 3 times 6 is 18. So 38 is 18, add 4y, and we're just going to solve that equation. Let me write it again up here. Let's start by taking 18 away from both sides. So 20 is what we'd be left with, and that equals 4y. I've taken away this 18, that's gone, and I'm just left with 4y. If 4 lots of y is 20, we're going to divide both sides by 4. So 5 is y, or y is 5 would be your answer there. Question number 17. Scott wants to make orange juice, and he's going to buy boxes of oranges. There are 24 oranges in each box of oranges, and 30 oranges make 2 litres of orange juice. Scott needs to buy enough oranges to make 8 litres of orange juice. Work out the number of boxes of oranges that Scott needs to buy. You must show all your working. So we know that 30 oranges are needed to make 2 litres. And Scott wants to make 8 litres. So what could we do to get from 2 litres to 8 litres? That is 4 times bigger. So if we're making 4 times as much orange juice, we need to also multiply the number of oranges by 4. And that would be 120 oranges. How many boxes do we then need to buy? So if I need 120 oranges, and they come in boxes of 24, we're going to divide by 24 to find out how many boxes that is, and that is 5 exactly. So 5 boxes would be enough. Scott also buys 1,260 apples and 280 bananas. Write down the ratio of the number of apples that Scott buys to the number of bananas that he buys. Give your ratio in its simplest form. So it says apples first and then bananas. So we're going to put 1,260 to 280 like that. Now both of those numbers are in the 10 times table because they've got that 0 on the end. So I'm going to divide both by 10 and say that that's 126 to 28. They're both even, so let's divide by 2. And that would be 63 to 14. and they're both in the 7 times table, so let's divide by 7, and that is 9 to 2. I can't go any further, there's no more common factors other than 1, and that wouldn't change it, so my final answer is 9 to 2. Question number 19. Adam, Linda and Ritis share an amount of money. Linda gets 3 times as much as Ritis gets. Linda gets half as much as Adam. What fraction of the amount of money does Linda get? So they've given us no values here. So when that happens, it's quite helpful to just say, well, let's give one of them £1, and then we can work out the rest. So Linda gets 3 times as much as Ritis. So Linda's getting more than Ritis, and Linda gets half as much as Adam. So let's go with Ritis, I think, is getting the least here, isn't he? So let's give Ritis £1. So we'll say Ritis is getting £1, and therefore we know that Linda is getting £3. Linda gets half as much as Adam gets. So 3 is half of what Adam gets, so Adam must get £6. Now they might not be their amount of money, but because it says what fraction of the amount does Linda get, it doesn't really matter. We could have given Ritis £10, and we could have given Linda £30, and we could have given Adam £60. It doesn't matter, because what we're about to do now is say, well, what fraction does Linda get? Linda gets 3 out of, and if we add it all together, 1 add 3 add 6, that's out of 10. So we could have made it 10, 30 and 60, and then she would have got 30 out of 100, which would have simplified, and it's the same fraction. So it really doesn't matter. So I'm going to go with 1, 3 and 6, and I'm going to say that therefore her fraction is 3 out of 10. Doesn't ask you to simplify it, so as long as you've written a fraction that is equivalent to that, you could write 6 out of 20, you could write 12 out of 40, that would be absolutely fine. Any of those fractions, as long as they were equivalent, you would get both marks there. Question number 21. Write 84 as the product of its prime factors. So 84, we're going to start with that at the top, and we need to think of 2 numbers that multiply together to make 84. Now you've got lots of options here. You could go for 12 and 7, you could go for 42 and 2. It doesn't matter what you use, okay? As long as if you get to a prime number, you're going to circle it, and that kind of stops that section and carry on with the other side. So 12 is 2 times 6, 2 is prime, so let's circle that. 6 is 2 times 3, and they're both prime, so they both get circled, and we are done. Therefore our answer is 2 times 2 times 3 times 7. Now that's actually all we need to write for both marks there. It didn't say give your answer in index form. If it did, you would have to write it as 2 squared times 3 times 7 with that indice for the 2 times 2, but either of those answers was absolutely fine for 2 marks there. I'm just going to write 2 times 2 times 3 times 7. You have to put it with multiplications in between. The most common mistake I see is with commas in between. That's going to lose your mark, okay? So with multiplication in between, so that when you times those numbers, it does indeed make 84. Find the lowest common multiple of 60 and 84. Okay, so we've just done the prime factorisation of 84. Now let's do the prime factorisation of 60. So 60 is 6 times 10. Neither of those numbers are prime, so let's go again. 2 times 3 makes 6, and 2 times 5 makes 10. There we go. And so 60 is 2 times 2 times 3 times 5. I'm now going to do a Venn diagram. This circle is going to be for 60, and this circle is going to be for 84. And we're now going to look at both this and fill in that Venn diagram. So they've both got a 2, that can go in the intersection. They've both got another 2, so that can go in the intersection as well. And they've both got a 3, so that can go in the intersection as well. I've got a 5 left over on the 60 that I haven't used, and I've got a 7 left over on the 84 that I haven't used. Now, if I'd asked you for the highest common factor, it would be all these numbers in the middle multiplied together. So the highest common factor, the biggest number that goes into both 60 and 84, would be 2 times 2 times 3, which is 4 times 3, so 12. So the highest common factor would be 12. If you want the lowest common multiple, you take that 12 and multiply it by any numbers left on the outside. So 12 times 5 times 7. So let's put that somewhere else, let's put that over here. Lowest common multiple is 12 times 5 times 7, any numbers left on the outside, which is 420. And you have got a calculator, so you can use your calculator for that one. This was a calculator paper. Fabulous, there we go. Next question. Question number 3. Carlo puts tins into small boxes and into large boxes. He puts 6 tins into each small box, and he puts 20 tins into each large box. Carlo puts a total of 3,000 tins into the boxes, so that the number of tins in small boxes to the number of tins in large boxes is in the ratio 2 to 3. Okay, so whenever I see ratio, I do find it helpful to do some little lines like this, so we know there are 5 parts altogether. We're sharing in the ratio 2 to 3, where this is small boxes and this is large boxes. Now, we know that there are 3,000 tins. So those 3,000 tins need to be split in that ratio. So we're going to do 3,000 divided by 5, and that is 600. So that means I've got 600 on each of these little lines. Now that tells me that there are 1,200 tins going into small boxes, and there are 1,800, because that's 600 times 3, 1,800 tins going into large boxes. Okay, great. We know that 6 tins make up one whole small box. So I know that if I divide this by 6, that's going to be 200 small boxes. And then I know that making a large box is 20 tins. So let's divide this one by 20. So 1,800 divided by 20 is 90. So we know that there are 90 large boxes. Great. It then says that Carlo says that less than 30% of the boxes filled with tins are large boxes. Is Carlo correct? So we need to know, is 90 30% of the total number of boxes? So there's 290 boxes in total. 90 out of 290, to get that as a percentage, we just times it by 100. So if I type that in my calculator, 90 on the top, come down, 290 on the bottom, times by 100, that is 31.03%. That's one way of doing it. Another way of doing it would be to say, well, 10% of 290 would be 29. You could times that by 3. 29 times 3, or 30% of 290, was 87. So then we can say no, because it's 90, so that's more. So he's saying less than 30% of the boxes are large. So Carlo is incorrect, as more than 30% are large. And you could say that 90 is greater than 87, but with the that would be enough, or seeing that and that would be enough. So lots of different ways you could have got 5 marks there, but there we go. That was it for 5 marks. Well done if you got that. Question number 5, work out the value of x. So this is a right-angled triangle, and we've got an angle involved. So that's telling me that this is a SOHCAHTOA question. So I'm going to pop my triangles up here, SO, CA, and TOA. And first thing we're going to do is label our sides. I want you to go over from the right angle. That is your hypotenuse. So this is our hypotenuse. Then I want you to imagine you are stood in the angle that we are interested in. In this case, it's the 34-degree angle. And you're looking into the triangle. Which side is next to you and which side is opposite you? So this side over here, that's opposite. And this side next to you here, that's the adjacent. And the adjacent is normally found between the angle you're interested in and the right angle. So there we go. What 2 sides are involved? Well, I know the hypotenuse, so that's helpful information. So I want to make sure H is in my formula triangle. And I want to know the opposite. So that needs to be in my triangle as well. Which of the triangles has O and H in it? That's going to be SO. So we're going to be using SO for this question. Let's do it again big down here. I didn't know the adjacent, it wasn't helpful information, and I also didn't want to know how long it was, so there we go, that's not involved. So now I want to know the opposite. You cover up the thing you want to know and do the sum that's left behind. Now remember that the S is sine 34. Had we have been using CA, then the C would have been cos 34. Had we have been using TOA, the T would have been tan 34. So there we go. Sine 34, and that's multiplying by the hypotenuse. So sine 34 times 178. I'm just going to type that in my calculator. and that is 99.53633. I always like to write what is on my calculator to a good few decimal places, and then I'll round it on the answer line. So it says to 1 decimal place, so that's going to be 99.5. Does that make sense? Well, yeah, it does. I don't need to put millimetres because it's x millimetres, so that's fine. The hypotenuse is 178, and that's the longest side, so I'm happy that that's a sensible answer. It's a shorter side, so there we go. Question number 7. The diagram shows a right-angled triangle and a quarter circle. The right-angled triangle ABC has an angle ABC is 90. The quarter circle has centre C and radius CB. Work out the area of the quarter circle. So to work out the area of a quarter of a circle is pi r squared. But then we know that if it's a quarter of a circle, we're going to need to take that answer and divide it by 4. You might also be happier with the idea of timesing it by 90 out of 360, and either of those are absolutely fine, okay? But either way, we need to know what the radius is. We need to know the radius of a circle. Now, the radius of a circle is that, but it's also that. So can we find out how long either of those lengths are? Yes, we can. We can use that right-angled triangle, and we can do Pythagoras. I know this is Pythagoras because I've got 2 sides, and I want to know the third side. So we're going to do 9 squared take away 6 squared. Now, sometimes with Pythagoras we add, and that's if we want the hypotenuse, and sometimes we take away, and that's if we want a shorter side. So because 9 was the longest side, the hypotenuse, and we had that, we wanted to take away here. So 9 squared take away 6 squared is 81 take away 36, and then we're going to get that answer, and then we are going to square root it. Always with Pythagoras, you want to square root at the end. So 81 take away 36, and the square root of that answer is 3 root 5, or you can write it as 6.708203932. Now, I don't really want to round it at that point, and I am going to keep it in my calculator because I now want to do pi times that answer squared. So in my calculator, I'm using my answer button. Pi times that answer squared, because I don't want to round it. And then I'm going to press equals, and I get 45 pi. And then I want to make sure I divide that by 4 or times it by 90 over 360, because I don't want the whole circle. I don't want all of this. I just want a quarter of that circle. So let's take that answer, divide it by 4 or times it by 90 out of 360. And that is 35.34291735. They want it to 3 significant figures. So there's your first significant figure, there's your second, there's your third. 4 rounds down, so 35.3. And we are in metres squared here. That's fine, the units are on the answer line, so we're okay with that. 35.3 is your answer for 4 marks. And last but not least, question number 29. Write down the gradient of the line with equation y equals 2x add 3. So all straight lines can be written in the format y equals mx plus c, and whatever number is here, the m, that tells you how steep the line is, the gradient, and whatever number is here, it might be a minus, it might be a positive, for either, is your y-intercept. So this number tells you where it crosses the y-axis, which is this axis here, so we know it crosses at 3. And then this number here tells you how steep it is. So for every 1 across, we're going up in 2s. So it's going to have a positive gradient of 2, and that's all we need to write. None of that we need to write. For 1 mark, all we need to say is that the gradient is 2. When it's like that and y is the subject of the formula, we're just looking for whatever number is in front of the x, that tells you the gradient. And that is it for that paper. I hope you found that helpful. 42 marks available for that one, so we'll have 38 marks next week, the rest of the paper, the even numbers. Let me know in the comments if you've got any questions, and I will see you next week for week 16.